Every second, third-party users and AI agents are generating dynamic code that runs instantly inside your microservices. But let me ask you, are you still running the untrusted code in your standard containers?
If you are, you're playing with fire. Standard containers are built for packaging apps, but they share the underlying host kernel. If an AI model hallucinates a malicious exploit or a user uploads a rogue script, a single kernel escape can compromise your entire infrastructure. Traditional container isolation is dead when it comes to untrusted code. This is where MicroVMs saves the day. They combine the blazing fast boot times of containers with the true hardware-level security boundaries of a traditional virtual machine. Instead of sharing a kernel, every piece of untrusted AI code gets its own completely isolated virtual hardware sandbox. In the open source world, two dominant hypervisors rule this space. First, there's AWS Firecracker. Built explicitly for serverless, it's minimalist, strips out legacy device drivers, and boots in milliseconds. On the other hand, you have Cloud Hypervisor, heavily backed by Intel and Microsoft. Written in Rust, it's modern but feature-rich, supporting standard PCI devices and advanced virtualization. It also provides GPU pass-through for workloads requiring isolated GPU compute, which is missing in Firecracker. But how does this actually look inside a production Kubernetes cluster? Let's break down the official Kata Containers workflow. Normally, when the kubelet wants to schedule a pod, it sends a request over the container runtime interface to container daemon. In a standard setup, container daemon talks to runc tool to spin up a normal container using shared host namespaces. But when you need extreme isolation for untrusted code, Kata Containers steps in. Instead of runc, container daemon hands the task to a custom shim. This shim instantly talks to your hypervisor of choice, like Cloud Hypervisor, to spin up a dedicated MicroVM. Inside that MicroVM, a tiny ultra lightweight Kata agent launches your container payload. To the Kubernetes control plane, it looks and behaves exactly like a standard pod, but to a hacker trying a kernel escape exploit, it's an impenetrable hardware wall. The best part, for developers, switching to this secure architecture requires zero code changes. You manage it entirely through native Kubernetes configuration. First, you register a customized runtime class in your cluster, setting the handler to Kata. Then, whenever your application needs to execute a dynamic AI-generated Python script or an untrusted third-party webhook, you simply add the runtime class name to that specific pod's manifest. Kubernetes automatically routes it away from the shared host kernel and directly into a secure virtual hardware sandbox. Now, managing raw Kubernetes clusters, hypervisor nodes, and Kata shims by yourself is a massive operational burden. That is why cloud providers are productizing this tech. Microsoft Azure handles this beautifully. If you need a raw serverless container primitive, Azure Container Instances spins up highly isolated hypervisor boundaries out of the box. But if you are building production-ready microservices, you look at Azure Container Apps. While standard profiles use shared or dedicated VM spaces, Azure Container Apps offers confidential dedicated profiles, the DC series. By deploying your AI apps onto a DC series profile, you get hardware-backed trusted execution environments. Your container's data is fully encrypted in memory while it runs. This means you aren't just isolated from other tenants. Your data is completely protected from malicious insiders or the cloud infrastructure itself.
Designing, deploying, and securing multi-tenant microservice applications like this can feel overwhelming. You have to balance scaling, networking, and intense security requirements. If you want to stop guessing and start building production-ready, bulletproof microservices environments, I've got you covered. I just launched my comprehensive course on Udemy, Mastering Azure Container Apps.
We deep dive into everything, from creating secure microservices using App Gateway and offloading authentication, adding with Container Apps environments network isolation using Azure's virtual network with private endpoints, implementing resilient event-driven interactions using Dapper sidecars, automated scaling with Kata autoscale rules and adding dedicated workload profiles, configuring ingress envoy and handling burst traffic using NAT gateway. Don't let your AI infrastructure be a security liability. Click the link in the description below, grab the launch discount, and elevate your cloud architecture game today. See you in the course.